Welcome. The next topic is the derivation for calculation of the depletion width of the PN junction diode. So to find the depletion width of the junction, consider the indigenous phase charge carriers due to the fact that donors on N side and acceptors on P side have lost their accumulating electrons and holes. So the charge will be Q naught. The potential energy is QV naught. Between the two parts, the potential is built across the junction. So lower potential here, P side of the junction is at lower potential than the N side. Here we are going to consider alloy junction in which there is an abrupt change in the acceptor ions on the P side and the donor ions in the N side. So this is the abrupt junction where there is abrupt change here, right? So suddenly the majority of holes here moves to majority of electrons here. So this is P side and N side. In between we have this depletion layer in which we have the ions here, negative ions in the P side and positive ions in the N side. And so the rho charge density is given here. For P side, as we have seen, it is less, minus QNA. For N side it is plus QND. This is abrupt or alloy junction. The same if we see for graded or grown junction, where there is less concentration in the center and more concentration of charge carriers in the sides. So this will be the charge density for graded or grown junction. And then this is the curve for electric field and this is for voltage. So here the voltage, the line is like this. So here this point is x. So this point is x is equal to 0 and v equal to 0. This one voltage, the left hand side, y-axis is voltage v. So v here, v1 in the bottom and v2 in the top. This point is x1 and this point is x2. Okay. So the charge density rho equal to, as seen here, it is equal to minus QNA in 0 to x1. 0 to x1 is this region. In this region, the charge density is minus QNA. And from 0 to x2, this region, the charge is rho equal to plus QND, and all other places the charge density rho equal to 0. So the potential variation in the space region can be calculated by using the Poisson's equation given by del square V equal to minus rho of xyz by epsilon naught epsilon r, where epsilon naught is the permittivity of free space and epsilon r is relative permittivity. Relevant equations for one-dimensional problem is d square v by dx square equal to minus rho by epsilon naught epsilon r. Applying the above two equations on the P side of the junction, d square v by dx square equal to, so in P side rho equal to minus q na. So that is substituted here. So it is minus q na, minus n minus gets positive, q na by epsilon naught epsilon r. So integrating it twice. So for now on first integration we get dv by dx is equal to qna by epsilon naught epsilon r plus c, and then on second time v equal to qna by 2 epsilon naught epsilon r x square by 2 cx plus d. We need to find the values for the constants c and d. So at dv by dx at x is equal to x1, dv by dx is equal to 0. So we have the value for dv by dx. So we equate that to 0 and we get the value for c. And then substitute that in the value for v, this v equation. So we get the value for d equal to 0. So v equal to, we have this equation. So v equal to qna by epsilon naught epsilon r x square by 2 minus x1 x. So as v1 equal to, v equal to v1 at x equal to x1. v1 equal to, so substitute v1 in place of v and x1 in place of x. So we have v1 equal to minus qna by 2 epsilon naught epsilon r x1 square, and same for v2 is written in opposite. So the total built-in potential on the contact potential v naught equal to v1 minus v2 or v2 minus v1. So we have the equation for v naught equal to. So we know the fact that the positive charge on the N side must be equal to the magnitude, equivalent magnitude to the negative charge on the P side. So Na x1 equal to minus Nd x2. So x1 is equal to, so substituting the above relationship. So in this equation, in place of x1, substitute minus Nd x2 by Na. So we get the value for x1 in the opposite. So we get the value for x2 also. So we can see total depletion with W equal to x2 minus x1, the points in the x-axis. So we, since x1 and x2 are power 1 by 2 terms, we write it as W square equal to x2 minus x1 whole square, which is x1 square plus x2 square minus 2x1 x2. So substituting the values for x1 and x2, we get value for W, the depletion width, which is 2 epsilon naught epsilon r V naught by Q Na plus Nd by Na Nd whole power half. We know epsilon naught is permittivity of free space, epsilon r relative permittivity, V naught voltage applied, Q charge of electron or hole, Na and Nd number of electrons and holes. So for this abrupt junction, W is proportional to V naught power half, considering all of the terms are constants. So if we go for the other ground junction, V naught will be equal to, if we V naught, W will be equal to V naught power 1 by 3 for ground junction. So this is regarding the depletion with derivation. Thank you.